This is Geometry Semester 2. It's the third unit called Solids, and it's the seventh lesson in that third unit called Volume of Pyramids and Cones and Slants Practice. The slant pyramids and slant cones, better known as oblique, is the proper term. Alright, so this is from creatormath.com under the Geometry tab. Here are the instructions. Copy the following problems 1 through 4 and follow those number of problems. Sometimes I'll have a lot of problems on the page. You only have to copy problems 1 through 4 into your composition book on the correct pages according to the table of contents with the notes for those pages. Don't forget the notes. I'm just going over problems here, not the actual notes. You're going to copy those from the separate file on the table of contents on creatormath.com under the Geometry tab. So this is dealing with volume. Given the following three-dimensional shape, what is the volume? Okay, volume is, I always try to explain it to students if you have a can of Coke, right? And volume is the amount of liquid Coke that fits in that can. That's what volume is. So it's a measure of cubic space that something fills up. And this, if it's a can of Coke, it's the amount of fluid filling that can. So that's what volume is. So think of pouring a liquid into this pyramid and then finding the volume is how much liquid would fit in there. So there's a hint. They say the volume of the pyramid formula is 1/3 side squared times perpendicular height. The side length is 6 meters, so this side length here is 6 meters. And the perpendicular height, they have a dimension here. It's a little hard to see. H equals 10 meters. They're talking about perpendicular. That means the angle at which the height dimension meets the base or the ground is at 90 degrees. It's very important. In other words, the side is slanted, so there's a distance here which is greater. We want the distance from top to bottom that is perpendicular to the base. And the other word for that is altitude. We don't measure the distance up to an airplane at an angle. We measure straight up from the ground or perpendicular from the ground. So they tell us the formula for volume here. They say volume equals 1/3 side squared s squared times perpendicular height. And if I can go perp height, I don't know, for perpendicular height, I don't know if that's a very good abbreviation, but where does this formula come from? You won't derive it until calculus, but basically speaking, if you've got a cube, right, here's a cube. I'm drawing it over letters, but see how you have a square base? And then put a point right in the middle and draw down to these corners. This creates a pyramid. So out of this entire shape, if this entire shape was length times width times height, right, or s cubed, the interesting thing is that this pyramid takes up 1/3 of this. That means if you cut away all this space, you'd be cutting away 2/3 of the cube space. So pretty interesting. You actually take the derivative in calculus to create it. But it's interesting that 1/3 of the cube is the volume of the pyramid. Then you can stretch it up to, like as in a rectangular prism, you could stretch the pyramid up higher, and that's why we separate out the perpendicular height from the actual s times s times s, right? All right. So 1/3 is our is in our formula here. S squared is the side dimension squared. We're going to put in both the number and the unit into that and square it. We're going to multiply by the perpendicular height, the number, 10, and the unit, meter. Why? Because we want to see these units come out in a cube. Cubic is the unit placed on volume. So volume equals 1/3. 6 times 6, or 6 squared, is 36. And meters squared is meters squared. We're still multiplying this by 10 meters. So volume equals 1/3. Well, let's do 1/3 of 36, right? Isn't 3 times 12 36? So let's get rid of this. 1/3 of 36 is 12. And I'm tempted to say times 10 here. So 1/3 of 36 is 12, times 10 is 120. We have meters squared times meter to the 1 power, which adds the powers. You get meter cubed. This is good because we know it's a volume. That's part of our calculation. It helps us understand that we did this right for volume. And if we come over here, 120 meters caret cubed is meters cubed, or meters to the 3rd power. Interestingly enough, we can take a pyramid and slant it over, right? It's called oblique, O-B-L-I-Q-U-E. When I was a student, I tried to say oblique, but it's pronounced oblique, and I guess I learned that later, and now I call it oblique, all right? So same thing, we're starting out with volume. It's 1/3, it's the side squared, and they tell us this here again, times the perpendicular height. And they do show us height here. It's the dimension's hard to see. It's a line coming here. This is a 90-degree angle to the base. That's why we call it perpendicular, because that's what 90 degrees, and that's what perpendicular means, is 90 degrees. So volume equals, let's see, the side length is 12 inches. So this is 12 inches here from here to here. And the perpendicular height is 10 inches. So we have this equals 10 inches. So 1/3, 12 inches, put the units and everything, and square it all together, times the perpendicular height of 10 inches. V equals 1/3. 12 squared is 144. Inches raised to the power 2 is inches squared. There's still a 10 inches in here. 144 times 10 divided by 3. Don't be afraid, and I'm going to model this for you, right? Don't be afraid to use your calculator out of your phone. Clear this out. Remember, you can slant it this way to see the extended calculator. We really don't need it in this case, but take your 144, divide it by 3, equals 48, and then just say times 10. We can do it all in one. I'm sorry, you guys. There we go. All right, let's try that again. So 1/3. 144, 10, right? Let's clear this out. So we say 144 divided by 3, that's over 3, or divided by 3, times, there's a 10 right here. So we get 480. So V is going to equal 480. We have inches squared times inches to the 1 is inches cubed. Again, we love to see that unit come out correctly. 480 inches caret cubed. That's the amount of liquid, like if you had liquid and we poured it into the shape, and maybe you had to turn the shape upside down, maybe turn the pyramid upside down, you could imagine easier pouring something into that. That's what volume is. The reason the square-based pyramid and the cone are placed together on the same assignment is that the cone shares the same volume formula, and, well, essentially the same. It's 1/3 radius squared perpendicular height. So I think I need a pi in there. Where's my pi? 1/3 radius squared perpendicular height. And remember, if this stuff causes us problems, we just go volume of a cone. In formula maybe we need to say. So pi r squared h over 3. They wrote theirs slightly differently, and this is where I'm saying right here you're going to need a pi in here, right? So this is going to be volume equals 1/3 pi r squared, and h they're using, I'm going to say perpendicular height. Oops, get rid of this so you guys can see. There you go. This is pi r squared, right? That's the area of a circle. And if you think about a cone, right, it's got a circle at one end and a point at the other, and it goes up. So this is the area of a circle. That's where this pi r squared comes from. 1/3 is because if you had a whole cylinder here like this, maybe I can draw this a little better. If you had this, a cylinder, and we took a cone out of that, this area of this space or volume of the cone is 1/3 that of the entire thing. So just like a pyramid, if you took away these parts, you'd take away 2/3 of the space if you carved it away. Interestingly enough, it comes out the same. So volume equals 1/3 pi. So let's see, radius. What do they tell us? Radius is 6 meters. So from here to here is the radius. That's from the center to the side of a circle is 6 meters. We're going to say 6 meters, put it all in and square it. Let's go times the h. The perpendicular height is 10 meters. So 10 meters here. So V equals 1/3 pi. 6 times 6 is 36. Meters squared is meters squared. Still times 10 meters. 36 divided by 3 is 12, times 10 is 120. V equals 120. We still have the pi in here. And we have meters squared times meters to the power 1, or meters cubed. So this is 120 pi meters cubed. What I don't like about these answers right here, right? I don't see a pi in there. So I'll go back and fix that by the time you guys take this in your assignment. Right, I'll make this correction for you. It's 120 pi. And remember, in high school, we don't put in 3.14 anymore. We leave it pi, because pi has all the digits of pi included, which are infinite. And 3.14 cuts off all those infinite digits. So putting in 3.14 is less accurate. It's more accurate to leave the pi in the answer. So we say 120 pi meters cubed is the volume of this cone. Let's do a oblique cone. It's got the same formula. V equals 1/3 pi r squared, that's the area of a circle, times the perpendicular height. Volume equals 1/3. Let's see what it is for this specific case. We have the radius is 12 inches, so 12 inches and squared, and the perpendicular height is 10 inches. And we used the same dimensions as the prior example, because the one prior on the prior page, because the interesting thing is, even though this thing's slanted, as long as we're using the perpendicular height, we still come out with the exact same formula, which I always find interesting. 1/3 pi 144. That's 12 squared is 144. Inches squared is inches squared. There's still a 10 inches in here times. So V equals 1/3. Let's do 144 divided by 3. We already said was 48, if you remember from our prior calculation, and we can just put it back in the calculator if we need to. Times 10 was 480. We still have a pi involved. It just sits there, and we say 480 pi. And then we have inches squared times inches to the 1 power, which comes out inches cubed, which we like because that's a volume. And we have 480 pi inches cubed, all right? So there's some things to correct here, here, and here. I'll go back and take care of that before you get to the actual assignment, right? So this is on creatormath.com. It's under the geometry tab. And just look for this exact title. You're trying to match up titles of the video with the title of the actual exercise.